In the last video, a lot of talk about why things are the way they are, a little talk about a simple problem, and then also one more challenging example. So let's jump into additional practice. Rewrite the second problem here, and I'll remind you and be thorough in my explanation of the first couple. I like to rewrite this and set it up just so we can see things stacked. And since we're told we need to use substitution, we know that it's always nice to be able to take the value of x and substitute it into the other where you're left with just y. Or you could take the value of y and do so with that. And it doesn't just have to work in this direction. You could also take this y and substitute it in there. But as you can see for this example here in problem 2, we need to rework it a little bit to make that happen. I'll briefly talk about planning ahead, but really you get better at planning ahead after you've done a bunch of these. There's a 3 in front of my x, there's a 2 in front of my y. I know that that means I'll have fractions later on. There's a 5 in front of my y. I know that that would mean I'd have a fraction later on. So it looks to me like getting this x by itself is going to be the most easy. So if this area has the problem rewritten, then I'm going to jump down and skip a line, rewriting the first equation and getting it to where x is by itself. So my plan is to solve for x by subtracting 5y. And here I have x is equal to negative 5y minus 3. You can box it, not because it's the final answer or anything like that, but rather because it's just a little bit of a creature of habit thing. You know, you're making parts stand out to yourself. So by here, we have x by itself. That's right, you don't have to rewrite that. And since x is by itself, we would plug it into the second equation. We wouldn't plug it back into the first equation because that's where it came from. That would get us nowhere. So we'll plug it in here. To make this stand out for these early on examples, I'm going to be really thorough in how I do this. So here's 3x minus 2y equals 8. We know that x and x are going to be substituted, and I also know that x is negative 5y minus 3. So then I'm going to write 3 times x, but I'm going to substitute negative 5y minus 3, and then I'm going to write minus 2y equals 8. If it's not clear where this came from, this is the same exact equation as here, but instead of x, I now have something with y there. Now you have to get it to where you solve for y. Negative 15y, as I distribute, minus 9 equals minus 9 minus 2y equals 8. Combining like terms, negative 17y minus 9 equals 8. Adding 9 to both sides. And for all of these problems, you really get a comfortable feeling when you do some division at the end of the problem and end up with an integer. So here I am with y being negative 1. When you solve a system, that's not quite enough to be done with it. You'd also have to solve for the other value of x. So there's negative 1. And so would it be easier to plug negative 1 in here or to here? I think it'll be best to plug it into the first equation because it just looks the most simple to me. I've got this room on the left, and so that's kind of what you end up doing on these problems. You kind of like zigzag a little bit to make use of a whole row of your page. So here I am with x plus 5 times y, which I'll write as negative 1 right now. That's not corner cutting because I think by this point it's kind of more clear, which gives me x minus 5 equals negative 3, and then adding 5 to both sides gives us x is positive 2. Lastly, we summarize our answer and write x comma y equals 2 comma negative 1 because this is a coordinate, and if it were graphed, this is where the two lines from this system of equations would run into each other. So 2, negative 1. I'm going to scroll all the way up top. I'm writing that in red just because it's good to check these problems in the original setup. So I got 2. 5 times a negative 1 is negative 5. And then 2 minus 5 does give me negative 3. It's not enough to check it in the first. You have to check it in both. 3 times 2 gives me 6. I see minus 2 times a negative 1 becoming plus 2. And I would say, well, 6 plus 2 does give me 8. Summarizing it, rewriting the original problem, picking the easier of the two to solve for, getting the x by itself, taking that value of x and substituting it in using terms of y. So that means it is written with y only in it. This equation here, it only has one variable, which means by the end of this algebra, we were able to find the exact answer for y. And then lastly, we substitute it in to solve for x. Many steps, but I think these are fun problems. Number 3, I might not talk about as thoroughly. Okay, so we've got the problem rewritten, and I'm looking at this, and it's like, well, okay, well, 3x minus 13 is already solved for. So I'm going to write 4x plus 5 times y, which is 3x minus 13. And that's going to be equal to 11. So that's this equation rewritten. And since y was already by itself, we didn't have to do all the work like we did here. Okay, and the last problem is what I was saying. So here's 4x plus 15x minus 65 equals 11. Combining like terms gives you 19x minus 65 is 11. Not really talking through all the algebra here. You can get caught up. And then you get like 76 divided by 19. And 19 is a prime number, and you're like, well, that's not making me feel great. But when you pull out your calculator if you need to, you get a whole number of 4. You get an integer. It feels good. Okay, so because this was a little bit less work to get to that point, we can make use of this space over here. And I'll decide, well, where would it be easiest to plug 4 in? I think this would be more steps than plugging it into 3x minus 13. So I'm just going to jump right into writing y equals 3 times, and I'm trying to change colors to make this stand out a little bit, 3 times 4 minus 13. 12 minus 13 gives you negative 1. Didn't write those y's until the end because they were implied. And then I'll be like, well, x, y must be 4, negative 1. And since I'm always modeling, double-checking these, let's plug that into the original equations. 4 times 4 is 16. Minus 5 is 11. And the reason I was able to say minus 5 is because it was times a negative. 3 times 4 gives me 12. Minus 13 does give me negative 1. So this checks out in both of the equations. If you ever look in the back of the book, it's always possible that if you're wrong, that maybe you just wrote the problem down incorrectly too. As this video approaches the 10-minute mark, I will set you up with the first step of problem 4 and then let you do it on your own. So pause this first to decide, are you going to get x by itself or y, and then do that first initial step. Hopefully you paused it because I'm going to show you how I would have done it. X minus 3y gives you negative 9, and then by adding 3y, it just really seemed like a lot less work to get x all by itself. If that's the starting point that you chose, great. If not, fix it. Unless you're really okay dealing with the fractions that came up. Take this problem through to the end. I'm going to put my answer up in a few seconds. x comma y equals 3, 4. You'll also possibly look at this and pause the video and compare it with your work. I didn't bother showing that I divided here, and I also didn't bother showing that I added 12 there, because by this point, you know, with all these multi-step problems, the hope is that a one-step equation is now kind of straightforward for you. So you're okay cutting out those steps. Pause this video and see if you can figure it on your own. It looks different, but if you see it, it's really not all that crazy, but sometimes this trips people up. I'm going to put the first part up in a moment. Now maybe you noticed that both times y was solved by itself. And if you really want to try to rework this and do a lot of fancy footwork, you're only adding more work for yourself. So if this is y, and this is y, then really all you have to do is jump right into saying 1/2 x plus 3 equals 2x minus 1. Because you would know that this is the same as that. You're just kind of jumping right in. But I know it's like harder to see. A lot of people don't like to deal with fractions, so if I doubled everything, my fraction would go away, and I would have x plus 6 equals 4x minus 2. Subtracting x from both sides gives me 3x equals 6. Since cutting a corner I was starting to get tripped up, I'll just go 6 equals 3x minus 2. Add 2 to both sides. Then I get 8 is equal to 3x. X is 8/3. Don't exactly get that warm feeling that you usually get, but a lot of times these end with integers, but it's not always a guarantee. So here's 8/3, and when I'm looking at this, I'm saying, well, there I'd be multiplying a fraction by fraction. Not a huge deal, but maybe you look at this one and you're like, that's fewer steps. So here's y being 2x, but x is 8/3, minus 1, and then I'm going to get 16/3 minus 3 over 3 to get 13/3. Time to summarize. 8/3, comma, 13/3. Box it. In red, I'm going to write this up higher. 8/3, comma, 13/3. Because you could plug this back in. Half of 8/3 is 8/6 plus 18 over 3. I'm doing all of this in my head. 18 over 6, gives you 26 over 6, which would reduce to this. Now that was crazy complicated. Type it into the calculator when you check it. 2 times 8/3 gives you 16/3. Minus 3/3 gives you 13/3. So as we scan through this, all together, that was the last problem that we did in the previous video. You just watch 3 different problems, some that required a little bit of rearranging. It's only coincidental that both times it was x. Some that required no rearranging. And then this last one that I didn't box yet, maybe that was just strange looking and the algebra became more complicated because fractions were involved. Also, these can all be typed into Wolfram Alpha. All you have to do is type an equation, put a comma, and then type the next equation and hit enter. And you will end up being given the answers to check to see if you're accurate on even numbered problems, or perhaps on an assignment where you can't check it with an answer key.